Let's explore JSON.stringify, a powerful tool that transforms JavaScript objects and values into JSON-formatted strings. It offers customization options and control over the serialization process. Here's a basic example. We have a user object with name, age, and skills properties. The JSON.stringify method is used to convert this object into a JSON string. The null argument indicates that no replacer function is used, and the to argument specifies the number of spaces used for indentation, which makes the output more readable. JSON.stringify handles various JavaScript data types differently. Strings, numbers, booleans, and null values are directly converted to their respective JSON representations. Arrays are preserved as ordered collections. Date objects are converted to ISO string format. However, undefined values, functions, and symbols are omitted from objects. In the case of arrays, these values are converted to null. As shown here, a JavaScript object containing a string, a number, a boolean, a null value, an array, and a date object is converted into a JSON string. Notice how each data type is handled. JSON.stringify has optional parameters that provide further control over the output. The replacer parameter can be an array of property names or a function used to transform values during the serialization process. The space parameter controls the indentation of the outputted JSON string. It can either be a number representing the number of spaces to use for indentation, or a string which will be used for indentation. Here's how to use these options. The space parameter is used here to format the output JSON string with a two-space indentation and a custom indentation. The replacer parameter in JSON.stringify can be a function, allowing for more complex transformations. This function takes two arguments, the key and the value. It is called for each key-value pair in the object being stringified. You can use this to mask sensitive data, format dates, or filter out specific properties. In the example here, we have a user object with a password property. The replacer function is used to mask the password with asterisks and converts the date object to a local date string. The output shows that the password has been masked and the date has been formatted. Circular references occur when an object references itself, either directly or indirectly. JSON.stringify cannot handle such circular references and will throw a type error. In this example, the user object references the friend object, and the friend object references the user object, creating a circular reference. To handle this, we can implement a safe stringify function using a weak set to keep track of visited objects. If a circular reference is detected, it replaces the object with circular string. As seen here, we are using the weak set to avoid the error by detecting circular references. The toJSON method enables custom serialization for objects. When an object has a toJSON method, JSON.stringify automatically calls this method to get the serialized representation. This is very useful for formatting complex objects. It is also useful when you want to add metadata to the serialized object. In the example shown, the user class has a toJSON method that formats the output object. It converts the last login date into an ISO string and adds a type property. The output shows the result of this custom serialization, where the date is formatted and type is added to the result. It is important to follow best practices when using JSON.stringify to ensure robustness and reliability. Error handling is essential. Always wrap JSON.stringify in a try-catch block to handle potential circular references and invalid data. It is also important to validate input data before serialization to make sure that the values are serializable. To manage the size of the output, it's recommended to use the replacer function to exclude unnecessary properties. Here's a practical example of implementing these practices within a safe stringify function. Validation is added before converting data into JSON string. A replacer function is used to ensure that large contents are replaced. Let's continue with more best practices for using JSON.stringify. Security is also important. You should never stringify sensitive data without proper sanitization. You can use the replacer function to mask or remove sensitive fields. For performance, you can cache stringified results for static data. In cases where you have large objects, you can use streaming or pagination. To handle future changes in the schema, you can include version metadata in the stringified output. In the example here, we have a user data to JSON function. It caches the output based on a cache key. It also masks the email address using mask email function and includes a schema version. All of these are part of the best practices to use while using JSON.stringify. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.